Hey, welcome back. We're going to do notes 1.5 here, solving equations and inequalities, including compound inequalities. So we're going to start off with just some basic linear ones that you've solved in the past. So we're going to use our distributive property here and distribute through this like a -1 there. Okay, I'm going to add like terms together here. 6x, 10 minus 12 is -2. This would be a -x plus 12. Get my x's together on this side, get my numbers together on this side, and divide. I have x equals 2. Okay, so here, this is hard for people sometimes. We want to get rid of the fractions. I think that's probably the easiest thing to do. So if I would multiply this all by 6, it'll work out. So if I have 6 times x plus 7 over 6, notice the 6 divided by 6 cancels out to give you 1, so you just have x plus 7. If I take 6, distribute it through, and multiply it by 2x minus 8 divided by 2, I have the 6 divided by 2 is 3. I can take that 3 and distribute it through. So 6x minus 24. Okay. Then here, 6 times -4 is -24. If I combine my like terms together, 7x, and if I take these and combine them and subtract them over to this side, or basically be adding them then, it would be -7. I divide, I have -1. At any time, feel free to pause this video and work it out yourself. When you're dealing with these, you could just work them out with a calculator, but if you want to work them out without a calculator, it's a little easier to get rid of the decimals. So this is 6/100ths. So if I multiply by 100, this would be 6x plus 9 times 15 minus x is equal to 7 times 15. Now you don't have to deal with decimals, and it's a little easier. So you have 6x plus 135 minus 9x is equal to 105. Combine your terms, get them to the other side, and divide, and you get x equals 10. Okay. Another approach to it is a graphical approach. So you can think about, if I graph these two lines, where are they going to intersect? Okay, what I mean by two lines is this. If you go to Desmos and type this in as one equation, and you type this in as the other equation in a separate line, you're going to get a graph that looks something like this. Okay, this point at where they intersect is where this equation is equal to this equation. They're both equal to the same thing at this point. And this point right here is the point 210. So this equation, really the same thing as up here, you can see is x is equal to 2. Same thing we had here is x equals 2. Okay. Another method is to use the x-intercept method, or finding the 0. To do this, we'd have to get it equal to 0. So if I would take it all, you don't even have to simplify it really. You can just go 10 plus 3 times 2x minus 4, and 17 here. So if I subtract that over to the other side, and if I take this and I add this over, and set it equal to 0 then, if I just graph this right here, my equation will look something like this, and it'll intercept right there at x equals 2. So different ways you can do it. You can do it analytically, the intersection of the two sides, or get it equal to 0 and look for the 0. Okay. Some special cases. If I tried to solve this, notice I go -x, the x's cancel out. I have 0 is equal to 3. If you look at that graphically, y equals x would be this, x plus 3 would be this. Notice they have the same slope, therefore they are parallel. And parallel lines will never touch, so there is no solution to this. We could also write it as the empty set. Okay, so if you wanted in set notation, it's the empty set. This one here, if you distribute through, you have 2x minus 6 is equal to 2x minus 6. Well, when is 2x minus 6 equal to 2x minus 6? What x's can you put in there so that this side will equal that side? Any number. So we could say x such that x is a part of all real numbers. Every number will work there. If you notice, if you subtract the 2x from both sides, if you do it analytically, you would have negative 6 is equal to negative 6. That's always going to be true for every number. Okay, so next here we're going to have a problem with CDs and cassette tapes. I thought I'd share with you some of my cassette tapes from when I was younger. So I remember back in the day in high school, we were listening to Tom Petty and the Heartbreakers, Steve Miller Band, Vanilla Ice to the extreme, Nirvana. These are some of my bands that I like to listen to. Motley Crue. And this is my most embarrassing one. Shaquille O'Neal had a cassette tape of him rapping. Shaq Diesel. Some of my most embarrassing ones. But anyway, during the 90s, CDs were a new technology that replaced cassette tapes. The percent of music sales that CDs held from 87 to 98 can be modeled by this equation right here. During the same period, a percentage of sales of cassette tapes could be modeled with this. Okay, what do you notice about their slopes? How are their slopes different or the same? Okay, notice the CDs have a positive slope. There's more CDs being sold every year and during that time. And here, it's negative. There's less cassette tapes. So more CDs and less cassette tapes as time went on there. Okay, so we're going to say 0 is equal to 1987. So we basically want to know where are those equal to each other. So if I have this equation, I want to know where that equation is equal to this equation. And if you solve that out, you'll get that x is equal to 4.8. And when you plug 4.8 back into either of those equations, you get a y that is equal to 42.08. Okay, what does this mean? Okay, well, it means, let's think about what our x and our y are here. Okay, the percent of music sales that CDs held, it can be modeled by this. X is the number of years, and this is the percentage of sales. Okay, so they were 4.8 years from here. So 87, 88, 89, 90, 91. Sometime in the year 91, 92 is when cassette tapes and CDs both held about 42% of the sales. And they were both equal there with that percentage. Then one overtook the other. So one of them was a positive and one was a negative. Here they're the same. You can see one overtook the other. Okay. All right, let's go to inequalities. All right, so with inequalities, you have to remember to switch the inequality sign when you're multiplying or dividing by a negative number. This back in Algebra 1, every single SOL test pretty much had one of those problems on there. Okay, so if we solve this out, we have 3x distribute through minus 4x minus 8 less than or equal to 2x plus 1. Combine your like terms and bring this, I'm just going to bring the 2x over to this side and the 8 over to that side. Okay. Now, right in this step here, we are dividing by a negative 3. And when we divide by or multiply by a negative number, we have to switch this sign around. So it's going to be x is greater than or equal to negative 3. Okay. Here, to get rid of the fraction, I'm going to multiply both sides by negative 3. So I have negative 6x plus 9. And negative 3 over negative 3 cancels, so I just have x plus 2. And since I multiplied by a negative, I have to switch that sign. Okay, and then combine your like terms. I have negative 7x is greater than negative 7 if you bring the x's to the left and numbers to the right. And divide by negative 7 gives me 1. But once again, since I multiplied or divided by a negative, I have to switch that sign around. Okay, number 8. Once again, distribute through. Negative 12x plus 12 greater than or equal to 4 minus x plus 1. Yeah, I can get all my x's on this side. I have negative 11x. Take my numbers over to that side, combine like terms here, I get negative 7. When I divide by negative 11, I have 7 over 11, and since I divided by a negative, switch that sign. Okay. Next problem here. When the air temperature decreases to the dew point, fog may form. This also causes clouds to form at higher altitudes. If ground level temp is T sub O and dew point D sub O, they can be approximated at an altitude of x miles by these two equations. Okay? So if T sub O is 75 and that's 55, determine the altitude where clouds will not form. Okay? So I'm going to set up the 75 minus 19x. Okay, plugging that in there. And the 55 minus 5.8x. And it will not form if this, okay, if the temperature is greater than the dew point. The clouds will not form there. Okay, so when you solve this, I'll just give you the answer here. You know how to solve. You get x is less than 1.51 repeating. So air temperature and dew point will be equal at this, miles above the ground level, and it will not form less than that amount. Okay, so if you go 1.5, a little over 1.5 miles up in the air, at this temperature and dew point, they will be equal. Okay, and then below that, clouds will not form. Okay, last topic, compound inequalities. Basically, you see two different inequality symbols, right? This is an AND statement. Okay, we can think about this equation, and we have that equation. We're inequality. You can see that we have two different equations to solve, or inequalities to solve. So, one way to do it is you could, okay, this is option 1. You could make the two different inequalities. So you have negative 3 is less than or equal to 2x plus 1. And your other one would be 2x plus 1 is less than or equal to 2. Then you just solve them independently. Subtract your 1 over and divide gives you negative 2. And subtract your 1 over and divide gives you 1/2. Okay. The other option is to solve it all at one time. This is a little easier probably, but a little confusing for some people, I don't know. So if I want to get x by itself in the middle, I'm going to subtract 1 from all the sides. And divide everything by 2. Okay, notice we have the same equations there. X is greater than or equal to negative 2. X is less than or equal to 1/2. And we can graph them down here too. Negative 2 is down there somewhere. 1/2 is up there somewhere. And it's less than or equal to, so we're equal to, and it's less than, and greater than or equal to this one. So greater than, these numbers are greater than or equal to. And we want, I told you in the beginning, this is an AND statement. So what numbers are greater than this and less than this? Well, every number in between there works. Okay, pause the video and give this one a try. Unpause it, come back and see us in a little bit. Okay, I'm going to subtract 5 from all sides. And divide by 3. Whoop. And you can do it the other way too if you want to, set up the two equations. So negative 7/3 down there somewhere, 5 up there somewhere. It's going to be less than 5, not over equal to, so an open circle. And greater than this number, so greater than there. So fits all numbers in between there. What? Then that is section 1.5. Have fun on your homework.